Welcome to your lesson on combinations. This lesson follows a previous video on Pascal's triangle. Make sure you watch that one first. Let's recap a couple things we saw in that video. First is the idea of permutations versus combinations. These are both ways of counting the number of ways you can select a small number of items from a larger set of items. We had the example of 3 students, and we were selecting 2 students out of those 3. In permutations, when you select neolids and takrina, for example, the students here, selecting neolids first and takrina second was counted as something different than selecting takrina first, neolids second. So even though it's the same 2 students selected, the order of them matters. Therefore, we get a larger count of possibilities. In combinations, we eliminate those ones where it's the same 2 items, like here. So the order is not important, so it just matters which 2 items you've selected. So in that case, we have less possibilities. Okay, we noticed also, or we learned that there are 2 formulas. For permutations, there's this formula, and for combinations, there's this formula. And we practiced that formula once, talking about what a factorial is as well. Make sure you're very familiar with that formula. Understanding it is essential for the next few topics. Then we connected that to Pascal's triangle, a wonderful pattern in mathematics. And in that, we noticed that each row in Pascal's triangle can be produced using combinations. For example, row 5, we can see 5 choose 0, running the combinations formula, we'll get a result of 1. And we can see the 1 here. And then 5 choose 1 is here at 5. 5 choose 2 is 10, is here, and on and on. Important to notice is row 5 has 6 terms in it, and that is because we begin with 5 choose 0. Okay, so with that, we're ready for a quick investigation. First step, find the sum of each of the rows in the triangle, in Pascal's triangle. So what's the sum of the numbers in each row? Okay, let's check. So here are all the sums, going all the way down. Well, the sum of the first row is obviously 1 because there's only a 1 there. The second row, the sum of those 2 items, 1 plus 1 is 2. Third row, 1 plus 2 plus 1 is 4, and so on, until we get to the last row here we have here, 64 is the sum. Now, do you notice a pattern in these? Okay, the pattern might be easy to see. We're just multiplying by 2 every time. And in that case, when you have a common multiplier, we call that a common ratio, and this is a geometric sequence. So what would be the rule for this geometric sequence? The general rule, we can notice the pattern also in this way, so I'm rewriting it in this form. Basically, this is 2 to the 0 power, 2 to the first power, and so on and so on. 2 to the 0 is 1, 2 to the first power is 2, 2 to the second power is 2, and so on. So we can clearly see the base of our exponent in our geometric sequence. So our rule would be 2 to the power n minus 1. And the reason we have n minus 1 is because this is term number 1. Even though this is row 0 in the triangle, we're still calling this term 1, term 2, term 3, term 4, and so on. So term 1, 2 has a power of 0. Term 2, 2 has a power of 1. Term 3, 2 has a power of 2. So notice the power is always 1 less than the term number, therefore this rule here, n minus 1. Now it says, find the sum of the 16th row. Well, this is important now how you interpret it. If this is called row 0, then row 16 will be which term, right? Row 0 is term 1. So row 16 will be term 17. So now I'm putting 17 in there. 17 minus 1, we have 2 to the 16th power. And that makes sense. In the 16th row, like row 6 had 6 power, so row 16 will have 16th power on the 2. And that produces this value here. Huge sum. So the Pascal's triangle values grow very quickly, and the sum will grow so quickly, all the way from 64 to this, so quickly. Okay, now let's move on to the second kind of problem, which gets us to think about combinations a little bit more. So imagine there are 2 boxes on a table, and you are asked to select up to 2 boxes. So up to 2 boxes means you can take no boxes, or 1 box, or 2 boxes. So if we think of the ways we can take 0 boxes, right, no boxes, how many different ways can you take none of these boxes? Well, there's only one way you can take no box, it's to take no box, right? So here's one way to take no box. Okay, how many ways is there to take 2 boxes here? Sorry, not 2. How many ways is there to take 1 box? Well, there are 2 ways because you can take either A or B. So there are 2 ways to take 1 box. And finally, how many ways are there to take both boxes? Well, that is 1 because there's only 1 way to grab both of the boxes, right? You take them both. So this shows the number of ways to grab the boxes. And this has a relationship to Pascal's triangle. Do you see it? I hope you do. We have those values matching row number 2. So think of row number 2 as representing 2 items from which we are selecting. And here, selecting 0 of those items from 2, here's selecting 1 of the items from 2, and here's selecting both items from the 2. And that tells you how many different ways that can happen. That's an important thing to know about Pascal's triangle, but also about combinations. So now, thinking of things that way, let's add a third box. So I'm going to add a third box to the table. Watch this amazing animation. Here it is. Box C has been added to the table. It's incredible how that just appeared. Let me show it one more time. Wow, I'm so proud of that animation. All right, so now you have 3 boxes. What are the combinations for choosing no boxes, 1 box, 2, and 3? So again here, we can look at Pascal's triangle. Now we have 3 items. So we're going to look at row 3. And 3 items can be selected in these combinations. If you choose to take no boxes, it's going to be a 1. And here we have choose no boxes, combination 3 choose 0, if you ran that formula, 1. And then choose 1 box, 3 boxes to choose from, we're selecting 1, that formula will produce 3 again, there's that number. Next, 2 boxes, we're choosing 2 boxes from 3, and we get an answer of 3, and that's that 3 there. And finally, if you ran 3 choose 3, it would be a 1. Again, why are these numbers what they are? Well, the first one, if you have 3 boxes and you're choosing 0, right, 0, that first number is always 0. Well, how many ways is there to take 0 boxes? Well, there's only 1 way. You take no boxes. All right, how about the 3 here? This is 3 choose 1. So you have 3 boxes. How many ways are there to choose 1? It's 3 because you can take any one of the 3 boxes. So there's 3 different ways to select a single box. And so on and so on. All right. So now, what is the total number of combinations? Well, the total is 8, because again, just like we were doing totals a moment ago, you can total up the values in this row, and it equals 8. Or we had the rule, remember, 2 to the 3rd power, 8. And it says repeat for 4 boxes. So how many combinations would there be across all the choices for 4 boxes? Okay, now that you see that clear relationship between Pascal's triangle and the idea of choosing items from a certain number of items, let's just practice with combinations for a bit. The first problems here ask you to use Pascal's triangle. So basically in this, let's go back. In this set of problems, you're going to be first using Pascal's triangle, then you're going to be using the formula, and finally you'll be using your calculator. So we're kind of practicing 3 ways to see the connection between all these ways. So again, let's begin with Pascal's triangle. Find this combination here looking at the triangle. And then find this one, this one, this one. Okay, here's the answers. The main thing here, or the main error that could have occurred is that, well, first you look at row 4. So here's row 4. We have 4 items and we're choosing 2. So 4 items choosing 2. The mistake students make is, okay, so I'm looking at this row here, and here's 1, 2. I'm going to go to the second term because I see a 2 here. No, that is not correct, right? Because the first one is choose 0, then choose 1, then choose 2. So remember to always go 1 further than the number you see here. So 6 is your answer there. In the second one, likewise, we have 6 choose 5. So we go to row 6, and choose 5 will be, well, let's choose 0, choose 1, choose 2, choose 3, choose 4, choose 5 is this number here, 6. Next one, 3 choose 3. And this is also showing you all the different ways to write a combination. You might see it like this, like this, like this. Okay, so 3 choose 3. We go to row 3, choose 0, choose 1, choose 2, choose 3 is here, and the answer is 1. Final one, 5 choose 3. Row 5, choose 0, choose 1, choose 2, choose 3 is this 10 right here. Okay, next we're going to look at some combinations using the formula, okay, without using your calculator. So do these with no calculator at all right? You need to practice the formula and feel confident with it. So this is the formula. And let's try it now for these ones here. Check your answer for this one first. Okay, so here's the answer for that one. Wow, it shows all the steps there. You don't have to feel like it just necessary to show all those steps. But here's it written out in factorial form. 7 minus 3 is 4. You may remember I showed this in the previous video. You have this means 7 all the way down to 1 all multiplied, and this is 3 to 1 multiplied, and this is 4, 3 to 1, and all these cancel, and it's nice that it shows that. So you're just left with 7 times 6 times 5. The bottom is 6, but that cancels. That's 6. So see how you can do this without a calculator? When you just use logic and cancel things away, you end up with a very simple problem. 7 times 5, 35. Next one. Actually do all three to finish off here. Okay, our answers are, let's see, there it is. Oh, let's go back. Our answers are 56 for that one, check your work, and 4 for this one, check your work. The last one here is going to be shown in a moment. And now let's look at the last step here. Find the combinations by using your GDC, your calculator. So in this case, it has a very high number here. So you don't want to do this approach. Now we're going to use that shortcut I showed you on the calculator, where you press math button, then arrow over to probability, and you can find a combination there, and then solve this combination here, and then this one. Okay, so let's check our work. Here's those answers. Whoa, huge numbers. Good thing we didn't have to do that using the formula. Good thing our calculator has a shortcut for helping us with that. So make sure you're really familiar with all three approaches and how they're all related to one another. Great work. See you soon.